Can you give me just 1 second? I'm like trying to get my papers all situated really quickly.
Sure. It doesn't really matter whether you're adding, subtracting, multiplying, or dividing. It's a factoring problem.
Sorry about that. Oof.
Okay. So this thing right here, what does that factor into?
Let's see. 2x and then 2x.
Oops, hold on.
And then
what's both signs have to be?
negative.
What are factors of 3?
1 and 3.
Does that produce the proper middle term?
No.
So what other choice? There's only one other choice. What is it?
The quadratic formula?
No? Don't forget you can split up 4x squared 2 different ways.
Oh, we can square root it?
No. In other words, it can be 2x times 2x, but it could also be 4x times x, right?
Yeah.
Now both signs still have to be negative. And now notice if you put the 3 there, it's going to multiply that 4, getting you big quickly, and that's what you need. And that works. That produces a middle term of minus 13x.
Mm-hmm.
Now, the bottom one's a little easier. We don't have very many choices on the 5x. How does the 5x squared have to be split up?
5x and x.
That's the only choice.
Yeah.
Both signs?
And the signs 1 plus and minus.
Nope. Excuse me. You're absolutely correct. So it's plus or minus, but it could be minus or plus, right? Which is going to be a different solution.
Yeah.
So when that coefficient isn't the same, you have to allow for both. Now, factors of 10. I got 2 choices. I got 10 and 1, and I got 5 and 2.
Yeah.
Which one should we start with?
10 and 1.
No, always start with the 2 closer ones. 90% of the time, the answer is going to be the 2 closer factors. In other words, 5 is closer to 2 than 10 is closer to 1. The top left was the exception, not the rule. Normally the top left would split into 2x times 2x. But in this case, it had to go 4x and x. Well, now, let me just give you a little secret here. We got to get to 23 in the middle.
Mm-hmm.
What, if I'm going to use 5 and 2, what does the 5 need to be multiplying for me to get up to 23? That 5 has to be over there. And furthermore, because it's a plus 23, it's got to be down there. Notice that the whole goal here is to produce the middle term. How do we produce 23x? Well, that's a good start because that's 25x right there. And the other factor is a 2. And that's 2x right there. Negative, excuse me, the 2 goes down there.
Yeah.
So it's negative 2x plus 25x. That gives you plus 23x. That's the correct way to factor it.
Yeah.
Okay, so I got 5x minus 2 and x plus 5.
Yeah.
Let's not do anything more until we get done. We're just going to do that. Can I factor that?
No.
All right, let's just write it. If you can't factor it, go ahead and write it. How about the bottom?
Yeah. It'll be x and x, and then plus and minus.
Now this case, because it's x and x, I only need to write one plus or minus. In other words, minus or plus is going to be the same thing, so I don't need to write it twice like I did in the previous problem.
Mm-hmm.
And then what factors, what are the next part?
9 and 3. And then the 9 goes with the plus because
Okay. Let's just keep going. Keep factoring. None of these are going to require the quadratic formula. And I'll tell you why. Because they wouldn't have structured it like this. In other words, when they give you problems where they are multiplying quadratic quotients, they never require the quadratic formula. You wouldn't come up with much of an answer if they did. But if you can factor it, like we are finding, we can factor every one of these pretty much, then you'll notice stuff starts to cancel out. So what's this top factor into?
X and then plus and minus, and then then it'll be 12 or
Verbalize that last rule for me. Factors of 36 that do what? That subtract to 5.
Yeah.
That's what we're looking for. Is we're looking for factors of 36 that subtract to 5. Well, that's 9 and 4.
Yeah.
The 9 goes with which sign?
The plus sign.
Okay, now we cancel everywhere where we can cancel. Cancel there, 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 there. There's a there and a there. There's a there and a there. You see why nothing's going to come out to be needing the quadratic formula? You wouldn't be able to do all this neat canceling if it required the quadratic formula. And the only thing we have left on the bottom is that, x plus 5. So that's your final answer for A. Okay? And that's exactly what we're going to do with all of these problems. Let me scroll up a little bit here. Easier said than done. That's okay. We'll do B. I'll just start writing up high.
All right.
What are we going to do with this?
Turn it to a multiplication sign and then flip the second term.
Flip and multiply. Okay. So let's start factor that.
The difference of perfect squares. So then it'll be x plus 3 and then x minus 3.
Okay. Factor the bottom.
And then that'll be x and x, and then it'll have to be plus and plus. Then it's 3 and 3.
Now, so we're going to factor the bottom. Does that factor?
Yeah.
Actually, it does not. Sum of perfect squares does not factor, oddly enough. So that's going to be our numerator. There's no way to factor that. Sum of perfect cubes, different story. but sum of perfect squares. Now factor that. That's going to go in our denominator.
That'll be x and x, and then it'll be plus and minus, and then it'll be 5 and 1.
No.
And 5.
What middle term we got to produce? We got to produce that middle term. 5 and 1 isn't going to do it.
Yeah, 6 and 1.
Again, let's go through that rule. It's factors of the number 6 that subtract to what?
So negative 1.
Just 1. In other words, whatever that coefficient is. Not really to negative 1, just 1. So what factors of 6 subtract to 1?
2 and 3.
Okay, where's the 3 go?
With the plus sign.
No, the bigger factor goes with the sign of the middle term. The middle term is negative, so the 3 has to go there. And the 2 goes there.
Yeah.
Okay, now again, we can cross off that, 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 that. And what we're left with is x squared plus 4 in the top. And you don't need to multiply that by that. It's better, in fact, to leave it in this format. That's because you don't know what needs to be done with this answer. Maybe we're going to multiply something else. And factored is always better than multiplied together. Unless, for some reason, these two things multiplied together equaled the quadratic in the numerator, and then you'd want to keep going. But that would have taken care of itself, because remember, we're always factoring everything we can.
Yeah.
Now let's add 6 to that, number C. How do we do this? How do you add fractions? That's what you want to ask yourself. This is actually 2 fractions. There's the first one. How do you add fractions?
You just add the numerators and the denominators?
No, that's how you multiply fractions. To add fractions, you have to find a common denominator, and then you just add the numerators.
Yeah.
So what is the common denominator there?
1.
No, the definition of common denominator is each term has to divide into it evenly. Well, I can't divide 1 by x plus 1. But I can divide x plus 1 by 1. And I can also divide it by x plus 1. So x plus 1 has to be the common denominator. If you always just multiply those two terms, you will get a common denominator. You won't always get the least common denominator, but you can always work the problem by getting any common denominator. Now, what's the top left have to be? If it has a common denominator of x plus 1, what does its numerator have to be?
6x.
I like writing it like that. I don't like writing it 6x plus 6, because if you write it the way I wrote it, you can instantly tell that that is the same as the number 6, right? The x plus 1s are going to cancel, and I've got my number 6. And that's what you're always trying to do here, is you're never trying to change the fraction, ever, with any of these problems. This is the same fraction as 6 over 1. What goes in the upper right?
Just 3.
Okay. Now we have a common denominator. That carries forward. We don't have to add those. And now we have to operate on the numerator. So now we have to distribute the 6 and then add the 3. So what do we get?
So then you get 6x plus 6, and then plus 3, so then it's 6x plus 9.
Okay. And that's actually our answer. Now, I suppose it's possible that if I factored something out of this, it would produce me with the same factors as in the denominator, and I could simplify it further. But I can see that's not going to happen. I could factor a 3 out of the numerator, and I would have this, but that's not a simplified answer. So I don't do it. In other words, if it doesn't really simplify it, if I happen to have a 2x plus 3 in the denominator, then I would definitely want to do that. But I don't. And I cannot simplify 2x plus 3 over x plus 1. They have to be the same, pretty much. Okay. There is one exception, and let's talk about it. We may not come to a problem that deals with it. But what is this?
Oh, I forget what that's called.
-1. What it is a minus b divided by b minus a. That's always -1. And the only reason I mention it is because this is the only thing where you can cancel and replace it without them being identical. In other words, 4 minus x is not the same as x minus 4. But I can still turn that into a -1, which is a simplification. So far, every single thing we've seen, you were only able to cancel stuff that was identical. Okay. So let's see, am I seeing all of D here? Is it 5 over x minus 10 over x squared plus 2x?
Yeah, it got like a little cut off, yeah.
All right. I might be able to scroll down, but now what do I got to do to the bottom right first?
You have to factor it.
Okay. You almost can be certain. It may not actually be necessary, but you can generally assume that if something is factorable, you need to factor it.
Yeah.
Now, what is, again, I'm adding or subtracting fractions. What do I got to do?
Find the common denominator.
Let's try to find the least common denominator in this case. What is the least common denominator? Again, I could always find a common denominator by merely multiplying these two things. But in this case, that's not going to be the least common denominator. Remember, each term has to divide into it evenly.
Would be x plus 2.
It's that right there.
Yeah.
Notice that that is divisible by x, correct? And it's also divisible by x times x plus 2. So it satisfies what we need from our common denominator, is it has to be divisible evenly by both terms. And now when I do it like this, it's relatively easy to figure out what goes in the numerators. This one we didn't do anything, so that's still a 10. What goes on the left?
And then that's 5 times x plus 2.
And write it like that, because now you can see absolutely haven't changed it. That's the same as 5 over x.
Yeah.
Now, we know what our final common denominator is. Let's leave it in factored form. Operate on the numerator. What do we got?
And divide, or wait, no. Wait, do you subtract the 10 from the
first of all, you get rid of parentheses. You got to get rid of that parentheses, which means you got to distribute the 5.
Oh, right. 5x plus 10.
And then minus 10 gives you just 5x.
Yeah.
Now I can cancel more. That x cancels with that x.
Which is 5.
My answer is 5 over x plus 2. And notice the advantage of not multiplying that denominator out. I might not have seen that. Had I multiplied that out and made it x squared plus 2x, then I wouldn't have seen the x cancels with the x so easily. So that's why it's good to leave stuff in factored form.
Yeah.
Is that the bottom of the page?
Yeah, that's the bottom.
Oh, good. I wasn't sure. And then we got another page here. Let's have a look at this. It's the same page. This log. Let me see what happens if I download this file. Look at the screenshot and see if it shows me those log problems. No, it does not. Can you easily take another snapshot of just those bottom problems and send it to me real quick? I'm not sure I can pull it up on the screen. When I click it, it doesn't come up. I get the next page. Unless, no, I can't, maybe. No, I don't know how to see that page so that we can deal with it. I tell you, I can work with this. I can read it, and I'll just write them on the screen. This is fine. You don't need to do what I just said. Okay.
Okay.
So we're only dealing with this bottom one, right? 5-128. They want us to use the definition of logs to compute what each is without using a calculator. So first of all, what's the base on that? It must be 4.
I think so.
Can only be 4, 1, 10. Can you read it? Are you looking at the original?
No, but I can pull it up really quickly.
Why don't you? Just, I'm 90% sure it's 4. It's just a little small for me to see. I can't magnify it.
One second here. It's a 9, or it's a 8.
Okay, cool. Glad I had you look. So now how do we solve that log problem?
So then it's 8 raised to the x is equal to 64, right?
Uh-huh.
Yep.
Well, what's x have to be?
2.
Okay. And when they say do it without a calculator, you know your answers are going to be whole numbers or fractions. They're not going to be irrational numbers.
Yeah.
Because you would have no way of getting the answer without a calculator. So, all right. What's the second one say? Log base what? B.
Log base 9.
Of x, right?
Yeah.
Equals 1/2?
Yep.
Okay. So what's next?
9 raised to the 1/2 is equal to x.
What is 9 raised to the 1/2 equal to?
Is that 3?
An exponent of 1/2 is the same as square root.
Yeah.
So it's the square root of 9. And it's positive.
Yeah.
Not plus or minus. And the reason it's not plus or minus is because x can't be minus. It wouldn't be in the domain. When you solve an equation by taking the square root of a number like this, generally your answer is plus or minus. But with logs, almost always one of the answers doesn't work. In other words, one of the answers is going to violate the domain, and you can almost assume that that's the case.
Yeah.
So always the thing you got to do with logs is check. What's the last one? 10 to the log. I'll bet this is base 10.
Yeah.
Of what? What's the argument? 4?
Yeah.
And
This
that's
is equal
equal to x.
Yeah.
Okay. Whenever you see this, and this is the same as that, what does the left side become?
Just
Whatever that is. So x equals 4. Okay.
oh,
If I had this, what's that equal to?
4.
Correct. Well, there's no matter what this number is if this number is the same as that base, the answer is that. Whatever it is, even if it was x squared, then it would be x squared.
Yeah.
Okay. All right. You have any more problems that you can verbalize, maybe?
Oh, we missed number C or letter C on that one.
So what is letter C? Log base what? Log base 3.
3 of 3 raised to the 4th is equal to x.
Okay. What can I do with that 4?
Do you
Bring it right down and put it in front of the log expression on the algebra line. In other words, it allows me to take my exponent of the argument and make it like that. That's the same thing on the left. Now, that helps a lot because what is the log base 3 of 3?
Just 3.
If I said to you, what is log base 3? Solve that equation, what would you do? You'd say 3 to the x equals 3. What is x?
Oh, it's just 1.
Okay. So that always is 1. As long as those two numbers are the same, doesn't matter if it's 3, 7, or 17. The log base b of b is 1. So since that's 1, x is 4. 4 times 1. All right, these are easy enough to verbalize. If you've got some more and you can verbalize them, let's just write them right. Let's do them right here.
Here, 1 second.
Particularly any that you find hard that you're not sure how to do. Oh, we didn't do the middle part. We didn't do this part here. Let's do those.
Yeah.
Because that requires some math knowledge. What is the first one? X to the third plus x?
It's x, x cubed plus x.
Okay. How do we tell whether it's odd, even, or neither?
Is it like the degree of the equation?
Well, in a way. But first of all, it's easier to think about this if we call it f of x instead of y. So first of all, we're going to do that. Same thing, same function. Okay? Now, the definition for an even function is f of minus x has to equal f of x. And the definition for an odd function is f of minus x equals minus f of x. Notice they're different.
Yeah.
Okay. And one way to remember this is remember that your even functions are like that. Your odd functions are like that. And notice that if I take that even function and I substitute negative x, I get negative x squared, which goes back to x squared. So it satisfies the fact that f of minus x is equal to f of x.
Yeah.
Same thing with the odd. If I substitute minus x for x, I get minus x cubed. So it satisfies that. So that would be odd. So that's the test we have to do here. Is we have to figure out what f of minus x is. And if it's neither one, then it's neither. Okay? So tell me, there's our f function. Tell me what f of minus x is.
So then negative x cubed would be,
Keep going.
and then minus x.
Is that negative f of x?
Yes.
Yes, it is. In other words, that's f of x up there. And if I factor out a negative sign here, I get minus x cubed plus x.
Yeah.
That is minus f of x. So therefore, this is odd.
Yeah.
All right. Now, you got these memorized? I'm going to erase them.
Yeah.
Okay. This time, we're going to use the second function. Can you read that to me? I'm going to call.
Y is equal to x squared plus x.
Okay. This time you work me through it and the logic and what it is.
So then we do, so it's x squared plus x and then negative.
So the first thing I should write is what?
F of
Test
x.
is what? The test is what is f of negative x. So you have to write that.
Yeah.
Now plug it in.
So then it'd be negative x squared is just x.
It's almost safer to just do this because it's really easy to make a mistake. Okay. So plug it in like that. And now simplify it. What's that become?
So then it's x squared minus x.
Now, is that either f of x or minus f of x?
Neither.
It's neither. In other words, I cannot turn that into, certainly not f of x, right? There's f of x. F of x is x squared plus x. And it's not negative f of x. We just saw that negative f of x is minus x squared minus x. So that's neither. Okay. And the third one is what?
X to the fourth plus x squared.
Okay, next step.
So then f of negative x. So then it'd be.
And
negative.
again, I wouldn't try to do that math in your head. And I'm going to tell that to every single student I have. Just because you don't want to make a mistake, you know how to do this problem. Don't make a mistake by trying to do two steps at once. Is that equal?
Then that's equal to x to, or yeah, f of negative x is equal to x to the fourth plus x squared. So it's the same, so it's even.
Perfect. And that's how you do it. It's always that test right there. You got to figure out what f of minus x is. All right. Now, I think we've done everything on this sheet. Maybe. Yeah, we did the third one, didn't we? How did we miss that set in the middle the first time through?
I'm not sure.
Huh. Didn't seem to come through. Actually, we didn't do the first two. We didn't do 2-178. Factor that. First one.
The first one would be 2x, and then it would be plus and minus.
Hold on. 2x and what?
X.
Okay.
And then it'd be plus and minus.
And since these two coefficients are the same, I've got to do it like this. Because plus minus is not going to necessarily be the same as minus plus. It's always the same if those coefficients are the same. But once they're different, you have to separate it like this. Now, what factors of 4 are we going to try? First of all, here's the factors of 4. Just experimentally, we're going to try which two first?
2 and 2.
Okay. And I'm just going to arbitrarily put a 2 there and a 2 there. What middle term does that produce?
That produces a -4.
The middle term comes from multiplying the inside, multiplying the outside, and adding them together. There's the inside. There's the outside. Add them together, that's the middle term it produces. That's not our middle term. And we can see quite readily that it's not going to do any good to just move the 2 down. I'm still not going to get to 7. I got to get to 7. So now I got to change something. There's only one thing to change. Let's use those factors, 4 and 1. In other words, we can't factor 2x squared any differently, but we can factor 4 into a 4 and a 1. And we're trying to get all the way to 7. That means we need a 4 multiplying, and it's got to go positive. So I know that 4's got to go with the plus sign. I know 2x times 4 is 8x, so I'm getting up there. And the 1's got to go there. That's perfect. That gives me 7x in the middle.
Yeah.
And that test is even more critical when you're doing these, what I call second degree quadratics, because you can't really solve it without checking that middle term. That's an integral part of the solution. When you're doing an elementary quadratic, you don't always have to do that step. I usually recommend people do it just because it checks the answer. But it's not nearly as important as it is when you have these kind of quadratics where they're not. In other words, what I call elementary quadratics is where it's x and x only. Okay. First step here. First of all, notice that this could be tough. Why? Well, there's multiple factors of 8 and there's multiple factors of 10. So I might have a lot of combinations to try. So what can I do first? I'm looking at all even numbers here. What must I be able to do?
Factor out of 2.
And that helps a lot because then it starts reducing these things. These quadratics become much easier the smaller numbers you're working with. Now notice that there's only one way to factor the number 5. So let's try it. And I can kind of get a couple of steps ahead here, knowing that, well, I got to reach the number 12. If I do 2x and 2x, am I going to reach 12? Actually, yes. 5 and 1. 5 times 2 will be 10. 1 times 2 will be 2. Add them together, that's perfect.
Yeah.
So I can, in other words, I'm always going to start with the two closest factors of 4x squared. I'm never going to start by saying that that's going to be 4x times x. I may have to go there. If I can't solve it using 2x and 2x, then I got to go back and try 4x and 1x. But this becomes a bit of an art as much as a math skill in knowing how you're going to get up to 12 in the middle. And I can see that I'm going to get to 12 really easy. That's 10 right there. That's 2 more. All right. So we've done all of those, I believe.
Yeah. And that's really all I had that I was like questioning on the study guide. So
Okay. You feel like you know your logs pretty good? It seems like you know your logs good.
yeah,
You know your
uh,
log expansion and compression? Is that something you need to know for your final?
I don't think so.
Okay. We won't go there. I don't want to go over anything you don't know. Let me just check out and see if you have been there. Or if I said compress that, how would that compress?
Um,
When you're adding two log functions, it's the same as one function with the two things multiplied together.
oh yeah, and then it's just log of yeah, and then you multiply and then subtracting, you divide.
Exactly.
Yeah.
So with logs, multiplication in the argument means addition, two log expressions being added, and you have to be able to go both ways. Just as important that you go backwards, in other words, that you be able to condense as it is expand. In other words, you want to be able to expand that one to the top, and you want to be able to condense that one to the bottom.
Mm-hmm.
So if you've been there, let me give you another one. First step.
All I can see is like the first log.
You can't see equal to 10?
Oh yeah, I can. I thought yeah.
Okay.
Um, um
The third most important rule of logs is this one. When you have the log of a to the b, excuse me, hold on, got to give it right. When you have the log of a to the b power, you can always take that b and put it there. That means that's equal to b times the log of a.
mhm.
Do that to that.
So then it can be 2 log of x is equal to 10.
Now what?
And then so then it's x
Always,
raised
hold on. Before you convert it to exponential, you got to isolate that. How do I isolate that?
divide by 2.
Okay. So now I got log of x equals 5. That's an implied base 10. So what's x going to be equal to?
And then 10 raised to the 5th is equal to x.
That's your answer.
Yeah.
Those are the only three rules you need to know about
Yeah.
logs, or when you're adding logs, subtracting logs, or when you have an exponentiation going on. This is the most important rule of all, or this one actually. That rule you have to use all the time to solve exponential equations. In other words, an exponential equation would be 3 to the x power equals 17. Now, if I want an exact answer to this, I can get it, but I can't give you an approximate answer without the calculator, oddly enough. And the way I get an exact answer for this is I can use log or natural log. I actually prefer using natural log. I take the natural log of both sides. Now that allows me to bring that x onto the algebra line. So now I got x times natural log of 3 equals natural log of 17. Well, these are both numbers. That means x equals natural log of 17 divided by natural log of 3 That's the exact answer. And I did not need a calculator for it.
Yeah.
Calculator's always going to round that number off, and you're going to have to end up approximating. So notice that what we started with was our variable was in our exponent. When your variable is in your exponent, whether you're doing interest rate problems or whatever, if what you're solving for is in the exponent, you're almost certainly going to have to use logs. Unless it's something simple like 3 to the x equals 9. Now I know that x is 2. I don't have to use logs for that. But if I say 3 to the x equals 8, I got to use logs.
Mm-hmm.
All right. Any other questions you want to ask, Blake?
I don't think so.
Your final is tomorrow or Thursday? Or
yeah.
Tomorrow? Okay. Well, I won't keep you. I don't know what to bring up if you don't have any questions. I will let you go. Blake, good luck on your exam.
Thank you.
You're welcome. Have a good summer if I don't talk to you again for next year. You're a junior this year or sophomore?
I'm a sophomore.
You're a sophomore. So you're going to be a junior next year. What are you taking?
121 and 122.
What is that?
College algebra. It's college algebra and college trig.
Okay. That's pretty much the same as pre-calc trig.
Yeah.
So, yeah, I'd be happy to work with you next year if you need help.
All right. Thank you.
You're welcome. Have a good one. Talk to you later.
Bye.